So I was asked by somebody about this bounds test for real zeros and polynomials, and in the lesson, they give us this information, and what I will share with you about this is I have found that if I pick the wrong value and it's not a zero, like this -12, it seems to work. It doesn't always seem to be working if the value is a zero to show this an upper bound, at least using this test. That doesn't mean it doesn't work. It just doesn't always work, I believe is what it's saying. So what did I do? How did I make this work? Well, so I've got this polynomial I created. I see that my lowest zero, it's a 4th degree polynomial. If you look at see, I made it be a 4th degree polynomial, 4 zeros. So that would be x to the 4th would be the leading term and the degree. And I'm seeing it's got a lowest zero that exists for this function is -5, and the largest zero that exists for this function is +6. So how does this upper and lower bounds test work? So what I did is so I expanded out that function. And when I expanded that all out, I came up with, let's see here. Actually, let me turn off the spotlight so we don't need that. Actually, I'm going to come back to pointer. Here we go. So when I expanded that function all out, I got, let's see. I got x to the 4th minus 3x cubed, or no, minus x cubed. Oh, wrong app. Here we go. So what did I say? I got minus x cubed minus 31x squared plus x plus 30. And then if you think about that, so the reason this exists is, suppose you don't have technology, you can't graph it. And this is pre-calculus. It was developed probably, I don't know when they came up with this, 1500s, 1600s. I would suspect the 1600s, because that's where they started to do a lot of the analytic geometry. So let's see here. So what possible zeros are they here? So if you think about that P over Q thing you studied earlier, remember P is the constant term, the last term in your polynomial. And we're going to list all the factors for that. Well, it could be plus or minus 1 and plus or minus 30. It could be plus or minus 2 and plus or minus 15, plus or minus 3 and plus or minus 10. And let's see, then it could be plus or minus 5 and plus or minus 6. And then I'll list the rest of them. Let's see, what do we do? Plus or minus 10. And I said plus or minus 15 and plus or minus 30, right? I think I got them all paired up. And then the leading term has a coefficient, or the leading coefficient is just 1. So I'm just going to be plus or minus 1. So I don't have to worry about any fractions for any possible rational roots here. So then I know there's a lot of choices here. What one do I want to pick? Well, suppose I didn't know that the lowest one was -5, because we looked at that graph. So what if I choose to try -6, say? And let's do some synthetic division with this. So 1, -1, -31, 1, and 30. Now let's run our division through it. So that's going to be -6, which is -7, which is going to be positive 42, which is positive, what is that, 11? And then -66, which is -65. And then I'm going to multiply that. I'm going to get, what is that, 390? And that's going to be what, 420? Notice -6 is not a 0. But what I am noticing is that alternating feature of the signs. And if you think back to look back at this, so I've got this situation where my 0 that I'm testing, or my value that I'm testing, is less than 0. And you see how the signs change, alternating signs, that last row in the synthetic division thing, that's what's happening here. So that suggests to me that I won't have any zeros less than -6. So So that'll let me rule out the -10, the -15, and the -30. So then if I try -5, then I'll see that it's a 0, right? And I don't think you need me to do that. If you do the synthetic division on that, you're going to end up with a remainder of 0 right here. So that tells you that -5 is a 0. How about a positive? How about an upper bound one? So then for the positive upper bound, I decided to try 6 just to see what happens. I know 6 is a 0 because I looked at the graph. And let me get a spotlight going here. So when I substituted in or did synthetic division with 6, I got a remainder of 0, which tells me 6 is a 0 for this polynomial. Notice that all positive thing about upper bounds didn't really work here. So I don't know, maybe there's a 0 out beyond 6. So then I tried running the synthetic division on 10. And when I ran the synthetic division through a 10, notice that last line. See, I know 10 is not a 0 because I didn't get 0 remainder. But notice that last line is all positive. So that tells me there's no zeros out beyond 10. That's an upper bound of possible zeros. It just happens that 10 is not a 0. So that would lead me to believe, well, let's go down one and try 6, which I did already. But what is nice about doing it this way, I know 6 is a 0, and I know there won't be any zeros out beyond that because that 10 is the upper bound. It shows that upper bound test. Okay, and since the only upper 0 would be 6, 6 and then 10, I know there's nothing in between there. So that's what this does for you to help. And yeah, granted, why learn this when we have graphing calculators? Well, being able to do the analysis of functions will help you in calculus, and that's part of why you're having to do all this. So hopefully this helps. Give a yell. Give a yell if you need help. Do some more questions out of this section on the ebook. I'm looking. Let's see where I'm looking at. I'm looking at this section about real zeros of a polynomial, and what is it? Questions number 20, 27, 38, 39, 40 are all the upper bound things. So, and then 41, 42, 43, 44 more lower bound things, and they have those problems set so it'll work. So, give it a whirl. Give a yell if you need more help.